So Hobbyist 3D printers have improved pretty rapidly in the last decade, and the market offerings today are the best they've ever been. Um, Today's budget systems pack in more capability per dollar than I would say Scott Crump, Bree Pettis, and Adrian Boyer could have collectively imagined in an AIM chat room during the formative years of RepRap. So the value of the hardware itself, just purely speaking of the hardware, is so compelling that you might find that the line between professional and hobby 3D printers is starting to seem a bit blurry. The low cost of a budget system like Prusa Reality makes it really easy for a mid-level manager or to purchase on a credit card or with whatever discretionary funds you have access to, and you can run them with interns and co-ops, right? So more expensive systems require some budgetary approvals, and there's always someone who's asking you, do you really need that? And the question kind of comes down to what your perception of time is, and what you are trying to solve at the end of the day. Today, we're joined by three panelists. They're distinguished colleagues of mine, Nate Sampson, Nolan Holliday, and John Bannon. They each run machines in their own time at home. And, besides being great design engineers for additive, they've also got good experience working on systems of their own. So I think probably the best group of people that I could have assembled for a forum like this. So let's do a quick round of introductions here. Nate, if you'd like to go ahead.
Yeah, thanks, Charles. So yeah, I'm Nate Sampson. I'm an application engineer here at Markforged. Going for about 2 years now. Been an awesome ride. Prior to my job here at Markforged, I spent some time in manufacturing industry between automotive, power generation, and aviation as a manufacturing engineer and a quality engineer. That's where I got my first taste of 3D printing. It was actually with a Lulzbot. And after that, purchased some Prusa printers at home at the Mark IIs with the MMU1 upgrade on the top right there. And then last summer, ended up getting a Prusa Mini. These are next to my Markforged Mark II and X7. So happy to be here and have some good conversation today.
Cool. And Nate's a prolific printer as well, and has done a lot of worked with a lot of different materials. He mentioned the multi-material upgrade. You can see some of that in action here. Yeah. On to the next slide. Nolan.
Hey, good morning, good afternoon, good evening to everybody, wherever you are. Thanks, Charles. As Charles alluded to, I am a colleague of his in the customer success engineer on our success team here at Markforged. Been with the company for about 2 years as well. And my background is actually an aerospace engineer by degree. I started my life in the, I guess you could say, the core aerospace business, and then moved on to actually pursuing my passion in automotive, which relocated me here to the Detroit, Michigan area, where I worked at Ford Performance in the NASCAR side of things. I got exposure to additive manufacturing in that role, and seeing basically how the professional application of it can work to develop new vehicles. And from that, basically gave me a sort of interest in it at home as well for the hobbyist angle. So you can see here my setup, somewhat similar to Nate's. I'll be a little more horizontal. It consists of 2 Mark IIIs Prusas, and one has an MMU 2S on it. And pictured to the right is my Markforged work printers, and also a Mark II and an X7. And then not pictured is in a little bit of a resin corner away from my work area is an Elegoo Mars printer. So I'm looking forward to the discussion with everybody this morning. And yeah, thanks for that. I'll turn it back over to Charles.
Cool. And Nolan's also done a number of really cool things as well. And it's fun to see what people are printing at home. And let's go next to John Bannon.
Hey everybody, and thanks for welcome to the presentation today. My name is John Bannon. I'm a lead application engineer here at Markforged, and I've been with the company for a little more than 2 years, and it's been an incredible journey. At my home where I work, I have a Mark II and an Industrial X7, as well as my personal printers. I have an Ender 3 V2 and a Creality CR10S Pro. And prior to Markforged, my career has been made up of different roles in both design, engineering, and manufacturing. And I spent a considerable amount of time as well as an application engineer and engineering manager for a SolidWorks reseller. And little fun fact, I was first introduced to 3D printing back in 1999 with an SLA color printer at university, and then got back into it again in 2010 with a Solido 3D printer, if those who remember those, as well as 3D Systems at the time. So really excited to be here and share my experience as well.
Awesome. So yeah, we've got a great round of panelists and a fun discussion coming up. This is just a bit of I feel like a user experience thing here. I like to use the side-by-side view, and so I copied and pasted this from somebody's like a Zoom guide to using Zoom. I didn't find out about side-by-side view until probably earlier this year, but you can see this panelist on the side. So it helps to, if you want to see who's talking, but totally optional, up to you what you prefer. So let's begin with a few questions. So I know you guys will have a lot of questions for us going into this presentation. So I want to start with a few questions for you, turn it back on you guys here. So I want to make sure that you get something out of this as well. And, beyond just us talking, we're going to have a fun time here, and we want to make sure that you have something to take away from this. Something that's really important to me personally, and I found in the last year, is that writing it down on paper makes me do it. If I type it into a note somewhere, or if I say I'll handle it later, I might not never get around to it. So I would recommend writing things down if that's possible for you. So the way that we're going to structure this, I think if you wanted to divide up your paper, I don't want to be too patronizing here. I think these are the core things that we're going to cover. So if you wanted to divide up your paper this way, we'll do quadrants while you're here. We'll have question 1 and question 2 and related notes to those, and then an area for miscellaneous notes. So that's just some basic housekeeping. So let's begin with question 1. We're going to count you down for a minute here. The question that I want to pose to you is, what is your time worth? This is a sort of a vague question. So think about that in whatever context you'd like, and take some time to write that down. What is your time worth? Cool. Hope you've gotten a chance to write down your answer. And we'll move on to question 2. Seems to have placed the video over some of the text. The question is, what problem are you trying to solve with additive manufacturing? And I suppose a final question, which I'm not going to take the full minute here for. Are you using a home printer for work? This is a kind of yes or no question. We'll just leave that one up and move on. So if there's anything that you take away from this presentation here today, we're going to talk through a lot of stuff. We're going to talk about capabilities. We'll talk about some of the parts. I see some questions in the question area about, like, some machines that you're comparing to. We'll go through a pretty comprehensive overview of what there is to know. If there's anything that you take away from this, it's more of like a high meta level thing. Work time is still your time. I know as the lines today are blurred between work and life, setting boundaries is harder today than ever before. And we've all done it before. We try to shoehorn or jury rig something into a, try to get a tool to do something that it's not supposed to do. It ends up blowing up in your face, and it results in you more time spent wasted in cleaning up, and then you have to do it the right way. So the two things that I want you to take away from this are that work time is still your time, and that you should choose the right tool for the task. So let's get on with it. So I would say there's a pretty fundamental difference between what a hobbyist and a professional do. I'd say that most of you here today are considering using 3D printers in a professional capacity, and that's why you're here. The difference that you're going to see is actually in the way that the company and that you treat your time and problems. So when you are a hobbyist, I would say that you likely have an abundance of time and you don't have that many problems to work on. So you're sort of searching for something to work on. And that's the way that the company is going to treat you too. They're going to assume that you have an abundance of time and that you're willing to spend it, and that you don't have enough problems to solve. So if they introduce a few new ones to you, it's not a big deal. On the other hand, if you're a professional, it's kind of the opposite. Chances are, if you're working professional today, that you don't have enough time to solve the problems that you need to solve, and there are always new problems coming up, always new deadlines, new things to work on. So there's a total flip that you now have a shortage of time and an abundance of problems compared to hobbyists. So when you're looking at the machines themselves, the way that we, at least at Markforged, would treat our customers is that we understand you have a shortage of time, and we also understand that you have an abundance of problems to solve. So the way that we address that is actually with functional capabilities. So when we talk about choosing the right tool for the task, there are a range of problems that you can address with 3D printers. You should choose the right one to do what you need to do. So let's take a little thought experiment here on off-road vehicles. So take a minute to imagine that you're an outdoorsman or woman, and that you now frequently drive off-road to reach destinations deep in the wilds of blank, Alaska, perhaps. What kind of car are you going to get? This is a bit of a metaphor, I would say, for what using hobby 3D printers at work might feel like for some people. Of course, if you're just trying to get around town, the humble Honda Fit is going to get you around town. It's very low effort, and it's not going to get you off road. It maybe in a pinch, but in order to get that Honda Fit off road, you're going to have to do some pretty extensive modification, and that modification work can be a lot of fun. You spend a lot of time planning, spend a lot of time building, but ultimately it's going to be higher capability, but it's going to require a lot of effort to do. On the contrast, the Chuck Norris version of the Toyota Tacoma here is going to be the highest. It's going to offer you a lot more capability, but with the same low effort, right? You're buying something off the shelf that works. And on the flip side, the Honda Fit upgraded is still require a lot of work, and it might not even be as capable. So let's get into why exactly we are offering a higher functioning product. So on the left here, you'll see the strength of our plastic matrix. And this, I saw a question here. Ross Wagner says, I'm comparing MakerBot method to what Markforged has to offer. And what we're looking at on the left here, the plastic matrix, that's what the general market offerings look like, right? We're comparing like nylons, polycarbonate, ABS, and you're going to see a range of flexural strength around the order of 100 megapascals, right? So Onyx sits around 81. But if you look over to the right, you might see, oh wow, there's like another chart that kind of goes up to the same height. But actually, if you were to funnel that down, the the strength of base polymers is very, it feels at this point kind of insignificant compared to fibers. Like fibers add the bulk of the strength to our parts, and so we're talking about the fiber itself. This is the level of strength that you're going to see, and that's why you're able to address a larger space of problems. So to put that into context, here's just like a kind of a comparison of what that means. We might be on Earth here looking at the tallest mountains on Earth, right? And we're thinking, oh well, ABS, you consider that to be Mount Blanc is 4,810 meters tall, and Everest, Everest is that thing that you're trying to reach, and that's really high. We're trying to get above Nile 12 CF, but in reality, if you were to look on a different planet, you would see mountains that are 10 times as high. So what that means, another way to look at this is, and this is a question that we get a lot from our current customers: how much fiber should I put into a part? How much do I really need? And if you just do a kind of basic volume fraction calculation, you can sort of see that by adding 20%, 40%, 60%, and I don't think we'll actually get to full fiber here, but we start to see material strength that's comparable, and perhaps even stronger than aluminum. And I wanted to tap on John Bannon here to see if you wanted to weigh in a little bit about like design for additive and so on.
Yeah, so we usually mention or talk about the fact that it's very, very geometry dependent. So for example, small parts that are designed for traditional subtractive methods that you want to make into additive parts may not be able to accommodate the full fiber strength right away. So you might spend more time on the design for additive manufacturing side, redesigning it or updating it so that your results can achieve that aluminum strength. So that design time for additive is time well spent because of the outcome and the strength of what the parts will have at the end.
Cool. Thanks, John. So when we talk about what that strength of that part means, is it's all well and good to have a strong part. I'd say that unless you had something that intentionally needed to break, which honestly is a sort of an application. Sometimes you don't want something that is too strong. You want it to break off. But there's a sweet spot anchored in low volume use cases for Markforged parts, and it extends a lot further beyond what you can typically make with a hobbyist system. So Nolan, do you want to talk a little bit about some of the applications that you've seen, some of the things that you've been working on?
Yeah, Charles, definitely. So I like this slide a lot because it sort of highlights really the range of what applications we've seen, either additive manufacturing, 3D printing, being talked about or being directly applied in the present sense and maybe even in the future sense. So where I'm at out here in sort of the manufacturing Midwest, I get to work with a really wide swath of what I would say core manufacturing companies. And in my experience, where I see usage of Markforged equipment specifically come in is the jumping off point is typically tooling and fixtures. So you can see in this quadrant chart that starts to live sort of in the sweet spot of really high business value with very good risk balance. So that's typically the jumping off point on our any customer's journey towards principles like designing for additive manufacturing and maybe in our case fiber selection, which then that level of experience can then start leading up towards higher impact or higher value, but potentially higher risk applications. And those are applications that are typically out of reach for a printer such as one of the hobbyist printers we have. So keeping that in mind, there is an area where it makes sense to have ownership of one of those and usage for one of those, but it's typically in maybe some of the more lower, very, very low risk, which companies typically low value in a business setting applications. So this just really kind of gives an ideal look at, kind of where this space is now and where we're thinking and our customers are thinking of heading.
Yeah, totally. And I've seen a lot of the same thing. I think when you've been using a printer for a while, you sort of understand what you can and can't do. And it's pretty quick how soon you say, I can't really do, yeah, I'm not, I don't, no way. Like, I'm not going to make a bracket for that fit, like that sensor. Like if it breaks, I'm going to be in trouble for that. Or no, I really probably shouldn't make forming tools because they're going to crack and break. So there's I'd say you know your tool better than anybody else, and that's it's going to be quick for you to develop some biases. So whatever your biases are towards the uses of 3D printing, I'd say based on the fact that we have these strong functional materials, reconsider what the application space is. It might not just be what you're thinking of today. So this is I have to admit, although we have high strength, we actually don't offer a lot of color options. In fact, the only color options that you have are black or white. And I'd say you only have the option for black. I would say like printing in color actually does have functional use cases. Like some people need parts that can be identified more easily. They might actually need a color prototype. So in that case, I'd say you would have to do an additional post-processing step if color is on your list of priorities. Cool. So let's do a quick jump into a customer spotlight. So to give you an understanding of what types of applications people are using, this is we just recently published a case study with NASA's JPL Team CoStar, and they're making autonomous robots to simulate the exploration of subterranean environments. I'll play a quick video here.
20 seconds.
Are we plugged in?
Yep. 10 seconds. Stand up. 5, 4, 3, 2, 1. Run start.
So you don't have to be a JPL to use something like this. I would say that a lot of people have important equipment that they're trying to protect, and this is one type of application. They have a $7,000 sensor that's needed to operate in low light environments, and so they use the sensor on top of a spot robot. And this robot is experimental, and so it needs to be protected. So they use a Markforged printed cage and currently have a number of machines that they're using to develop, I'd say, I think upward of 15 parts on their robot. So this is one type of application, of course. So the next topic that I want to get into is really related to time and effort around using a 3D printer. So I see a couple questions around handling particulates and the various aspects of the printer themselves. So to get you, this is a sort of a topic on getting you to the baseline. If you wanted to print stronger base materials, so not even considering the fiber reinforcements, what you would need to do to get there. There's a bit of a process, and I'm not even sure if any of us have done the full process of upgrading the hot end, the nozzles, like the fans, the enclosure, all that stuff. I think we've done close to it, but the general process looks a bit like this. So if you're looking to take a hobbyist machine to professional capable, you're going to do some research that might take a few weeks, on and off. Then, if you're diligent about that, you purchase your parts. There's a purchasing lead time. You unbox, you upgrade, you assemble your machine, you dry it. Then you have to dry your material, and you do a lot of testing, and then maybe you're ready. With a professional machine, you're sort of ready to go. So I think this is the good time for us to dive in a little bit and talk about, what are the major differences that we've noticed in this process of building, and what is that like? Nate, do you want to talk a little bit about how you got to where you are with your enclosure and your system and all that?
Yeah, sure. So going back to, I believe it was 2017, when I got first involved with 3D printing, I did a lot of research. I had almost no idea what I was getting into. So starting out, right, that initial research stage of even just what features are important, what are you looking to purchase, what materials are you looking to run, and then trying to trust, who do I want to trust with my time and my money to kind of get this going. And yeah, once you even get that system in and installed and up and running, and realizing that you may need to do some upgrades, it takes a significant amount of time, that's for sure. I probably spent several weeks doing that at the beginning. And yeah, and even my personal printer, getting that set up, doing the enclosure, 3D printing the parts for that enclosure, which I was printing in ABS, which mostly requires an enclosure. So you've got the problem of needing an enclosure to print the parts for the enclosure. So it's kind of funny there. So that took quite a bit of effort to do just by itself. And yeah, especially getting into these onyx type materials, it takes a significant amount of knowledge, which a lot of you, if you're in the hobbyist world and have spent a lot of time with your printer, doing a lot of research, you probably understand what it takes to get there. And then also getting the right material, getting the settings dialed in, ensuring your filament is nice and dry, very important for these nylon materials, which give you the superior properties that you're usually looking for. So yeah, firsthand experience, and even doing a lot of that in a professional setting. Looking back on it, this webinar is spot on with how much time it takes to get up and running, and really take a step back and focus on how to spend your time wisely, especially in the professional world.
Yeah, I think Bannon, you've got a different approach, and I didn't use your picture here, but I think this is sort of similar to your setup. To give you an idea of like what it looks like in reality after you've done all these things, Bannon, how did you decide on your setup?
Yeah, so for me, having no enclosure, I had an Ender 3 with a runaway thermistor that caught fire, luckily, while I was in the room. And So for peace of mind for myself, I went ahead and purchased fireproof enclosures that are separate from the printer. But there's a couple of benefits here. One, definitely, the peace of mind and safety required, like wherever you're going to put it in your house or in your garage, and that's where mine are right now, in the garage. Keep the industrial equipment in the house, in my office, and then my hobbyist printers out in the garage. But it also, in addition to that, I'm able to print more consistently because I'm able to achieve higher temperatures. And some of the benefits are that I have better gains in quality of the parts that are coming off of my Ender and Creality CIR10S Pro, and the results are more consistent. So for me, there's less time because I've dialed it in and I'm able to see more consistent results. So that's been really, really great.
Awesome. And Nate, your setup is I think based on the IKEA lac build that that Prusa put out. Is that right?
Absolutely. Yeah, these are like $15 end tables from IKEA. Right, 3D printed kind of corner pieces to attach acrylic to, which gives it a nice view from all sides. Got some LED strips in there so you can get a good look at your print as it's coming out, right? So you can see if any of the settings need to be tweaked. Yeah, that was the first print kind of project that I tackled when I got the Prusa Mark IIs.
Sweet.
And if you're like me, you just haven't got around to building your enclosure yet. So just don't print any materials that don't require the required enclosure.
Yeah. I saw a question. So Ross, your question for handling particulates given off in the air. I'd say that the enclosure, for the most part, for whether you're hobbyist or a professional printer, having an enclosure is pretty important for this. We've done air quality testing at Markforged, like not just on the printer itself, but actually in the entire office to see where particulates land. And I would say that not like I think our paper that we published, and you can refer to us later for it. 99 point some percent of the particulates are trapped within the printer. There's like no significant amount in like particles per million that escape the printer itself. So it's largely contained within the enclosure. So I hope that answers your question. And Nolan, upgrades can be a lot of fun if you got the time for it. And I think Nate probably had his amount of trials and tribulations getting his built, and Bannon ultimately had to make a decision on it. It can be fun.
Yeah, and one thing, Charles, I'll add really quick to that is that it can also be really educational. So, I mean, you really do understand the mechanics of a 3D printer and different styles of 3D printers by going that route, and so it does give you an appreciation for sort of what goes into it. So, and it can be a lot of fun. It's a bit of a mad science, I guess.
Yeah.
Yeah, whether like you're upgrading from a Volcano or a direct drive because you want to print flexible materials, it offers, the hobbyist printers offer additional capabilities.
Yeah, for sure. Let's take a quick moment to answer some of the questions that we have in the chat. I see a number in here. Let's see. What type of tolerances can Metal X? So we're not quite talking about Metal X today. So the question is, how kind of tolerances can you hold on the Metal X system on bore IDs and shaft ODs? I'll give you a quick answer here. I would predict that we're around the order of like 0.5%. So Metal X is a system that we sell that is another order of magnitude higher than this range that we're talking about between professional and hobbyist. I'd say it makes you a near net shaped part, which is similar to a casting. You'll still want to do post machining afterwards. Alan has a question: will additive manufacturing ever be deployed as a competitive alternative to subtractive? And I think we probably each have a slight bias here on the answer, but what Nate, Nolan, John, what do you think? Have we done any parts which could have been done in subtractive?
I guess I'll chime in first. Yeah, I mean, specifically if you're talking about subtractive with materials of things like engineered plastics or aluminum, those can right now today be addressed by our machines printing in either onyx, pure onyx, or reinforced with one of our fibers. Continuous carbon fiber would be the one that could give you competing material properties or competing part performance to that of a subtractively machined, like say 6000 series aluminum part. So that's already being done today, and beyond just replacing subtractive for like low volume, high mix parts, it also gives you the ability to maybe do geometries that are either economically very, very difficult or just physically very difficult to do on even like a 5-axis CNC equipment.
Yeah.
If you guys have anything else to add to that.
Oh, that was great. Just to reiterate quickly, right? The continuous fiber absolutely opens up applications. A lot of machine parts coming from aluminum can be replaced with our continuous fiber reinforcement, requiring less effort, right? Less skilled labor, lower costs, all the above.
Yeah, yeah. I also Alan's got another question about sheet metal. So I'll take a quick jump in here. So sheet metal has some pretty unique capabilities which are associated with the way that it's made. You're going to have a directional strength in a number of different directions. So that and the fact that you are working with a fairly thin material. I'd say with composites, replacing sheet metal parts is not really one-to-one. You wouldn't make a prototype sheet metal part by printing a sheet metal part. But you could, of course, prototype if you were trying to house a number of components, you could certainly do that. If you were trying to hold a number of components in a certain orientation, you could also do that. Your design would just end up coming out with some design for additive involved. So that may or may not make sense for you. If what you're looking for is prototyping something that you're going to make in the orders of like 10,000 a month, you may want to do the functional prototyping using composites or metal, but then ultimately your sheet metal design, if what you're trying to achieve is whether your production design will achieve your intent, then printing it may not be your best option. Cool. I think we still have a number of questions. We'll get to those in a couple more slides. So bringing this back down to the hobbyist discussion, I think we can all agree that the educational aspect and the building aspect of a hobby printer and upgrading can be a lot of fun. And that to say though, if you have to do it a number of times, I'm not sure how much fun it would be. I think it's fun. A lot of things for me personally are fun the first time, maybe the second time, right? Like you've done something once, you're learning from your mistakes. Second time you say, oh, I'm getting really good at this. Imagine having to do this now 3, 4, 5, 16 times, right? It might get a little bit old. As you can sort of see, the effort for building this doesn't get that much easier by doing more machines. You still ultimately have to do a lot of work. There's still a lot of lead time involved. And meanwhile, with the professional solution, you can scale that same solution over and over again. And you're not going to really see any differences between a machine that you implement here in the States or if you implement over in Germany or in Japan. It's the same machine that's being built by the same manufacturer, held to the same quality standards, and then delivered in that locale. A big area here that I want to highlight is the accountability model for different types of 3D printing solutions. So this is I'd say a pretty touchy subject, probably in the 3D printing world, but the difference between open source and closed source. I think there's probably some sentiment that closed source is like, oh, like these people are trying to profit off of me. They're not here for the community. And there's the kind of opposite here with open source, where we're saying, oh, it's all for the community. We're all trying to reach a better future. And there's I have a lot of I I have like pretty strong feelings about the open source community. There's like a really great case to be made for it in that by crowdsourcing development, you're actually letting a lot of people test a lot of different things at the same time, and it opens it up such that there's everybody can feel involved in the development. Sometimes with a closed source solution, unless you're closely tied with the manufacturer, you might find that it's a little harder. But what that comes down to for you as somebody who's maybe not necessarily participating in the open source community, but somebody who is, um, uh, let's say, benefiting from it, there are a few things that you have to know here, and it's that support and troubleshooting, updates and upgrades, those are in theory owned by everybody, but what that means for you is that it's actually not owned by anybody. It's on you to support and troubleshoot your own machine, and it's also on you to update and upgrade your own machine. There's nobody who's like a full-time job it is necessarily to develop for the open source community. I'd say out of the goodness of that person's heart, out of the kindness of their heart, they might give you, they might build a lot of things for you, but they also don't have any real reason to be held accountable. Meanwhile, with closed source, I'd say that we're going to see that the vendor actually requires, like in our case, like we define success by you solving high value problems. If you don't solve high value problems, then our machine isn't useful for you. And what we want that to look like is actually that you are solving problems using our machine, and in that case, we all benefit from that. So the accountability model for open source and closed source really comes down to open source. Nobody's really accountable, so you take on a lot of the risk. Whereas with closed source, you know what to expect when you're coming in, and there's an established relationship with the vendor. This I wanted to highlight here a little bit of like what it feels like to actually then jump in, and what happens when you run into a problem. So Nolan, I'm going to tag you in on this. We were talking about some of the accountability issues, and what do you do when you run into some challenges with your printer?
Yeah, so this is a great snapshot, and this is often what you have to do unless you have sort of an in real life community, which these days in this past year have been basically non-existent. You have to kind of turn to the good graces of the larger 3D printing community on online forums such as Reddit. And again, it's the kind of thing where you're probably going to get maybe 3 or 4 different opinions on everything you're showing, and it requires a lot of your time then to start to like kind of apply the scientific method or do this level of troubleshooting to try usually one of these things at a time, hopefully one at a time, and not maybe all of them at once, and try to get to the bottom of things. So that is one aspect of it. When you have a lower cost machine, basically what's not baked into that is the amount of direct OEM or factory support that you would get with something that's more professional and oriented towards an audience or a market where the time is very valuable and response time is very valuable. So you don't have a local reseller or a support like OEM support to go to. So you really just again, you're just working together with other people out there like you who maybe have bumped into the same problem. And this is a Benchy I have not produced yet. Like this is pretty good here.
John, Nate, any wisdom for troubleshooting, diagnosing issues that you've run into? Feel free to share good things too if you found some good resources that you can access.
I think the Benchies up there tell a pretty good story.
Yeah, whether you're running Benchies or temperature towers or cubes, you're going to do your own, troubleshooting, and that's a lot of research and time. And in the open source community, there's, like Charles said, there's tons of different opinions on what it could be, but it's like there's so many other variables, which just cause additional challenges for you as a user from the material, the firmware that you're using for your printer. I mean, it's just a list. And when you have something that's more like closed source, and you have a dedicated support team working for you to help solve those challenges, you come to solutions much more quickly. And it's a different experience.
Yeah, definitely. Let's I think I still have a number of slides here, but I wanted to take another round at answering questions. So let's do a quick speed round here. So let's see. Applying threads to parts. So Jessica's got a number of questions on technical use cases here. So applying threads to parts. Currently, my company uses heat set inserts, but I was wondering if there was an alternative option. I think that heat set inserts are great, and that's my preferred way of doing threads. If threads don't need to be like, if they're not used often, like if it's a one-time secure type thing, I might just undersize the hole a little bit and thread directly in. Guys, do you have any thoughts on threads?
Yeah, I would say if the hole's sufficiently large as well, like I think when you start getting a little bit larger hardware, then directly printing it again, yeah, is okay if it's like a one-shot deal. I think the preferred approach for like a real like engineered and functional part would be with the threaded inserts, the heat set inserts, particularly the tapered kind, like the nice kind, like ball out a little bit and don't get the cheapies, and insert them in from the backside if at all possible. If not, you can do something like on a Markforged machine. You can insert a pause and put in like some captive nuts, or design in a slot to slip in like a square nut after the fact. I think we have some blog posts on the subject too, so if you want to check that out.
Yeah. Jessica's got another question about dyeing white nylon parts. I think the white nylon actually does take dye pretty well, and because it's a water-based dye. At least that's the one our blog suggests. It's a little bit different from paint in that it does penetrate into the part to some degree. You're not going to see it. Well, you may find that the color may transfer to another white surface, for example, but it won't necessarily disappear entirely. Like it will be, I'd say, some fraction of a millimeter deep into the part, in that it's absorbed into the surface as a dye. So that hopefully answers your question there. Got a number of questions about dissolvable support structures. For our current set of machines, we do not do dissolvable supports, and I'd say that it's an experience for me personally that I've had a pretty bad experience with dissolvable supports. I used a dimension system back in school, and it was this I don't know if it was I think it was a alkaline solution that we put it in, and it's just like it was this thing that you had to do at the end that you weren't really anticipating, and I think our surface finish on supported surfaces, because we're using a carbon fiber nylon, is actually really great. There's a situation certainly where you would want dissolvable supports, but in a lot of cases, I'm doing a design for additive and trying to remove those supports, or simply designing it such that supports wouldn't necessarily factor in. So let's see. Cool. I'm gonna jump a few more slides in. This we might just skip, but I think it's related to troubleshooting. The way that you actually get to upgrades, that research pathway, I wanted to highlight that. I watched a ton of videos, and I still haven't done anything. Like, I gotta imagine that Nate, John, and Nolan, you haven't built your enclosure either. It's like educating yourself is not like with such a wide amount of information isn't exactly easy. You have to filter and discern for yourself whether the information is trustworthy. Somebody posting on the internet is not necessarily an authority on a subject. Although, based on view count, maybe you could say that some some things are pretty good. And I think when we're talking about the accountability model here for what we're calling the digital forge, it's a way for us also to develop robust features and improvements that work across the entire user base. I think a lot of the work that you do as a hobbyist is not scalable, and it's intentionally so because it's a different thing that you're building each time, and it's a lot of different iterations across a lot of different people. I think there's a really cool thing about the open source community in that like somebody can discover something which then maybe gets absorbed into the broader source code. But for us, we take it a sort of a different approach where we're developing the features in-house based on feedback that we get from you and pushing those down. One of the, like some things that come to mind are the preventive maintenance schedule. So we have a consumables tracker now that actually tells you, sort of like an oil change light, that tells you what needs to be changed on your machine. And it tracks your usage, and that's all implemented on the printer directly. And we set that over a cloud update. Certain features in the slicer, like automated build plate packing. You know, if you're printing a lot of parts, you can pack those all in. And quality features, I think, are a thing that's like, this is normally on you as a hobbyist. If you run into issues like print issues, like Dan, what do you do when your temperature towers aren't working?
Yeah, it's constantly going back to the drawing board, understanding like what's wrong, looking at the materials, looking at the range of materials that filament, you're usually given a range. It could be up to 50 degrees or more. That range can be dialed in, and it all depends on what printer you're using and the specifics that you need to run at. So there's lots of different challenges.
Yeah, it's stuff like this where it's like, you know, these are things that you might deal with, but as a result of us seeing it and you telling us, we fix. So it's I think the model is a little bit different, and there are advantages to each model here. We're also really invested in your success. Like I touched on this a little bit earlier, but like we don't succeed unless you succeed. Like we're not just here to sell you a printer and stop picking up the phone. I think if you sort of look at the business model for a lot of different 3D printer companies, you might see that some benefit the most from selling you a piece of hardware. They want you to buy a lot of hardware, right? I'd say we're invested in your success. We want to make sure that you are doing something useful so that you continue to use our printer. And that's a sort of a testament to that is that we have online education software or education program that's built to make you successful by choosing the right applications to solve with the right tool. And you know, I know we're running up a little close to time here. I did want to highlight that we are actually currently running a promotion, and I'm not sure if I'm supposed to tell everybody about this, but we're running this, I think, until the end of March. So if you need to get budgetary approval for Mark II, it's probably a good time to consider talking to whoever you need to talk to. It's currently 15% off right now. So let's. I think we can still go back to some Q&A. There's
I'll take a common theme here in some of the questions.
Yeah.
Basically reiterating a lot of what you were hitting home through all these slides here. What kind of experience are you going to get between an Ultimaker type, maybe that's considered a prosumer printer versus the Markforged solution. And the biggest thing to take into consideration is time. So I've learned that firsthand trying to implement a prosumer printer at work. It takes a lot of time, and your time is quite valuable, especially when you're on the clock. So the Markforged offers this digital forge. It's everything that is necessary to have a great experience. We've got the Eiger, which includes slicing software, printer management. We've got Markforged University to help ramp up printer adoption and design for additive, designing with carbon fiber. We produce our own high quality materials, in the United States. Hardware. We provide the total solution, and the digital forge makes it easy to be efficient and solve problems and not waste time.
Let's see. I know some of you might have to go. Sorry if we didn't get to your question. We have a list of these questions, so we'll follow up with you if you didn't get an answer. Let's. I think, yeah. What we still want to, yeah. What we want to hammer home here is that like you should value your time. And when we're talking about these systems and like what you're trying to do with it, consider your time in this process. With that, I think we'll hang on for a few minutes and keep answering questions. But thanks everyone for joining today. I hope this is informative. If it wasn't, please send us feedback. I need to know if what we're doing is useful for you. I think if you're looking for if you agree with us now that time is your greatest asset and you're trying to save time and you want some more information on our products, we offer a lot of the spec sheets, a lot more information on our website, which recently was revamped and looks quite nice, if I must say so myself. So let's. I think we can. Yeah, you're free to go at this point. If you want to hang on for more questions, we'll stay here for a few more minutes. Let's see. So P. Brown says, we are a custom machine builder. We're looking to get our first 3D printer to make one-off parts, test, or try ideas. They need to have good surface finish and tolerances. What is a good entry-level machine from Markforged?
Oh, I can take that one. I would say that is probably the ideal fit for a Mark II if you're interested in replacing machine parts, machined aluminum parts, particularly on your automation machines. If you do not need the strength or stiffness, then probably a step down on our desktop series would be something like our Onyx Pro. But that's, I think, assuming your machines that you're building are kind of what I'm envisioning and what I've seen for custom automation machine companies in this area. That's a great machine to have as a companion to your designers, basically in the cubicle or in the desk next to a designer, to just basically churn out parts as a workhorse. The build envelope is a little non-traditional. But it really lends itself well to packing it full of custom bracketry and connectors for things like extruded aluminum.
Let's see. Other questions? So build envelope. So an anonymous attendee has asked why. So the difference between build envelopes. It's hard to go down in size once you've noted you've used a Prusa machine. So yeah, the build envelope size for a machine is varied. So if you're looking at a desktop machine, we prioritize length in one direction, because what we noticed with a lot of our customers is that they have a need for parts which are typically long in one axis, and especially for fiber reinforced parts. I would say that building with some axis in mind is typically good practice. So with the desktops, we have a maximum X length of 12 inches. I think 330 or 320 millimeters. And if you're looking at something with a more uniform XYZ, we're probably the X7, which is 10 by 8, 13 by 10 by 8, approximately inches. And yeah, I think build size is something where it's like we tune this for the best thing that we had for our customers at the time. Certainly, if you have large parts that need fiber, get in touch with us. Let's see. Wasn't at the beginning of the presentation, so this is Roque. But my question is, when comparing setups, quality and results for printing, how you compare? Oh no, actually, Nate, you already answered this one. Subscription fee for Markforged University. I believe we offer it on a per seat basis, and it is around $1,500 per seat, and it's a multi-day course. So I'd say consider it like like an online course. And we do offer a lot of the information on our website. So if you go to the Learn section, you'll see a lot of the basics there. So take a quick look through the Learn section there first. And if there's additional stuff that you want to know, if you want to become proficient at printing with fiber, I think like it's the advanced techniques are what you get with Markforged University. I'd say that if you're just starting out, my personal opinion is that it's best to go through the Learn section, learn about the materials, try it yourself first, get the experience, fall a few times, and then if you think, I really need to be better at this fiber thing, that's a good time to jump into Markforged University.
So there's a question about post-processing, and there's a lot that we can do with our materials that we do with our materials. So anything from traditional like vapor smoothing that you might do on a hobbyist machine with ABS, you can do with our materials. It just uses or requires an additional piece of hardware from a company like AMT, which allows you to vapor smooth nylon. In addition to vapor smoothing nylon, once you have that porosity that has been removed, because you now have like this amazing surface, even more amazing than the silky smooth surface that Markforged gives you, you do have the ability to electroplate our material. So we do have customers that are making, cabinetry brackets and handles that look chrome, even though it's printed out of on a Mark II, and then they go through an additional process. So that can be done with other service bureaus that we work with, or customers that are actually doing this themselves. So there's lots of different ways that you can post-process our materials. You can sandblast it, you can sand it. So you'd start off at like 120, 220, then you'd go work your way up in terms of the fineness of the sandpaper so that you can get exceptionally smooth parts. And the tolerances that we're able to hold are really good, like plus or minus 5 thou on parts, whether it's feature specific or overall lengths. So we have a number of different capabilities that would allow you to dial in exactly what you need for that end solution, or making it for someone else.
Cool. I see Diogo has a question about a broader business plan for selling and expanding abroad. So we have a reseller network base across the world, and if you don't have any specific one in your country, we certainly get in touch with us directly, and we'll try to put you in touch with the reseller there. Yeah, if I'd say that we have a presence in almost every region of the world, maybe with the exception of Russia. So let's if you're looking to get some Markforged printers, get in touch with us, and we'll put you in touch with the local reseller. Follow up for Jessica's question. So Jessica asked earlier about dyeing parts, and the application would be on quality fixtures that would contact car paint. I think the best thing to do here would be to test it. I would say if you wanted to dyed nylon part to contact car paint, I don't think that it would transfer, but you should certainly test. You can always do coatings as well. Nylon is a non-marring material, so whether you're using Onyx, which is the carbon-filled version, or you're using just the nylon, it should be okay with car paint, unless it's wet car paint, in which case I'm not sure. Let's see, Brent has a question. I understand lumber building materials retailers are currently experiencing difficulties with their supply chains. Previous Markforged presentation it's mentioned that Markforged was successful with print on site. Will we soon be able to print needed general use parts at our local LBM retailers as an option to printing at home? That's a really intriguing proposition. Having a fleet of deployed printers out in the field. It's certainly, we have a lot of different service bureaus. So I would call the service bureaus our customers as well, but in a way that they also they're not using the parts as end use themselves. They are making parts for customers. So while you might not be able to find find a Markforged printer at a lumber building materials company, you will be able to find a service bureau in your area. So Brent, I would encourage you to get in touch with us if you're looking to find access to a printer near you. I'd say in a lot of experiences, after you've paid the service bureau a few times, which, you know, I don't want to downplay the importance of the bureau. If you need to try something out, the bureau is a good place to go. But once you have a certain volume of need, which actually is not even that high, it makes sense to get it yourself, because you not only can you get it faster, it will cost less. So hopefully that answers your question. And I'm glad that you attended that last webinar on supply chain. I'm sure Daniel Lazier would be very happy about that. Cool. I think at this point, hopefully we've answered most of the questions. The video in the presentation, that I was actually trying to throw up an audio clip. Sorry about that. If you're reading this, it's too late. That's from that's a Drake song, and the reference was just I'll admit it. That's all I wanted to do there. So sorry if that was confusing. Joaquim here is asking, so I like to tinker and upgrade as well, as well as the plug and play quality. What options do I have as a tinkerer with upgrading a Markforged printer? Or is it hands off and keep the creativity for other printers? Panel, what do you think?
The machine itself is relatively hands off, right? That's sort of the crux of it. However, I would say maybe your tinkering can then turn to tinkering on better parts. So the time investment is not necessarily spent in the art of 3D printing, but really the art of the printer is just a means to an end, and your end is your end result of your part. So that time spent is probably better invested in optimizing the part for additive strengths and some of the key capabilities that additive manufacturing provides. But yeah, in general, the only things I've seen is maybe a couple little mods people have done for Markforged printers. Just some of our customers out there have did things, just basic things like handles to kind of snap on our clear hood to keep the fingerprints off of it and things like that. So maybe a little bit more in the way of cosmetic upgrades, let's call it.
Yeah, that's a great way to go about that, Nolan. Markforged University, we offer courses to train you in the use of our printers in specific, and the ability to add continuous fiber and getting really crazy with the way you're using the fiber, maybe some non-traditional methods, off-the-shelf hardware, whether it's the heat set inserts, detents, embedded nuts. You can get as crazy as you want. Sensors. There's a world of tinkering that you can do with the design for additive, essentially tackling new projects that you didn't think were previously possible. So
awesome. I did see a few hand raises here. If you have a question, feel free to type it into the Q&A area. I will still continue to answer here.
No, so while we touch on it a bit, a really great point for Markforged printers is the ability to pause a print at any layer that you want, and you can actually build that in using our software called Eiger. So what I find on the Hobbies machines is that if I want to pause a print, even if I wanted to stop the printer directly where it is, it doesn't work on a Hobbyist printer. Like I have to wait like 30 seconds for it to figure out that I wanted to stop it and for it to take place. Whereas with Markforged, you can actually build that into what, especially with what Nathan was talking about in regards to like embedding off-the-shelf components. So if you knew that you wanted to put in a captive nut, you would allow the printer to print the features that would enable, that would look like the recess for that nut. And then you could pause the print. You can remove the print bed from our printer. It uses a kinematic mounting that it's precision to within 10 micron for repeatability. So you can take that out, you can remove supports, add your captive nut, make sure the nut is at the same level as the last layer is printed, then put the print bed back in, and then restart or resume the print, and it will print over, capturing that hardware directly in the print. So it's an in-process, both inspection as well as capability that we offer that's unique in the industry. And something that once you start working with it, you're like, wow, it's kind of an amazing feature. And it's something that I constantly use. And with helping develop and design what we call composite prints, where it could be a combination of, hard composite materials or metal and plastics.
Yeah, some of those hybrid parts are that I've seen come out of the applications team are pretty awesome. It's we're talking about like machine tolerances. I think some combination of if you do have specific tolerances, like making the bulk of your part using a composite printer is a really good way to get the positional accuracy of a lot of features. If you have like a very tight tolerances on a specific bore, you might consider putting an insert in. So whether you're making that insert yourself or you're getting that off the shelf, don't feel like you're limited to inserts as threaded inserts. There are plenty of other types of inserts that you can use. I think at this point the questions have stopped. We're 17 minutes over the hour. So for the 74 of you who are still here, thank you. And I hope that we can have another one of these sessions. Please send us feedback. I don't actually even know the best way to send it. Like perhaps just email me. I'm Charles at Markforged. If you have any specific feedback on this webinar or things that you'd like to see in a future webinar, please let us know. And thanks again to Nate, Nolan, and John. You guys were awesome, and I even see that as a question that we got or a response that we got that this was informative. So I hope that was the case, and look to talk soon. All right, thanks everyone.
Thanks everybody.
Thank you.